The stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause the stream is about to start. Get ready wherever you are, 'cause the stream is about to start. Hello everyone and welcome to another meeting of the C++ Digital Signal Processing JUCE and other things study group. Hello everyone, how are you all doing?
Very good.
Hello, doing great.
Yeah, so with me is Fotis as well as Alessandro. Am I pronouncing your name right?
Yes.
All right, so to start things off, how are things, Alessandro?
Going great so far. Like I got a basic version of my program running and it seems to work somewhat.
All right,
And
tell us all about it.
okay, so I plan to do like a program to transcribe music. So you could like with like a slow down function, so you can and repeat function, and you will be able to do annotations to the software to the song.
Nice.
So far I'm implementing the time stretching algorithm, and I found some paper about different approaches that I'm implementing, and so far I implemented like a simple overlap add algorithm. It's like the simplest version of a time stretch, and it seems to work, but it sounds horrible.
All right, so I have many questions. Do you want to start by showing us what you have? Do you want to start by talking about these algorithms?
I mean, I can talk about the algorithm a little bit, and I'm not sure how I'm going to do that because I'm in browser now. I'm not sure how I...
Oh, it does have share screen, I think.
Can I?
It is kind of annoying. The first time you want to share your screen, it will ask you for permission. Well, that's a Mac OS thing. Forget about it. You are on Windows.
I don't see screen share in browser. Maybe it's because I'm using Firefox.
Well,
No,
one
I
thing
don't
you
think
can
that's
always
the
do is you can join the call on the desktop version of Skype.
yeah.
And then mute your microphone, that wasn't working anyway, and don't enable your camera there, but start the screen share from there. That's what we did with Jaden when we had him over last week.
Okay. How do I... No. Where's my browser?
Meanwhile, hello Bo, hello Tail, hello,
Hello.
Beats, Bait, LN, Baitel, Bestel. Sorry. I don't know how to pronounce your name.
We have
Is the feedback over?
Oh, it's over.
Well, it's over now.
I was
But the screen share
sharing.
is gone and your camera is off.
Let me try again. I can hear myself now.
Yeah,
By the
the
way,
feedback
guys,
is gone and the audio is good. It was just Yeah, Bo is saying that was spacey. Yeah, it was just feedbacking,
was spacey.
and now your camera is off and the screen share is off.
Sorry, I'm going to be AFK for a minute, okay?
Okay. And
Going
now
back
everything
to
is working. Your
BRB.
screen is, sure. So your screen is showing up. We can hear you. We can see your desktop.
Okay.
There are just two huge blobs in your desktop. I think that those are the Skype windows. Yeah, they're gone now. Perfect.
Can I mute people in this Skype?
Sorry, what was that?
Okay.
Okay, while they're
Hello?
sorting things out, yeah, a Bestel is German for crafting. Crafting beats. Makes sense. Good to know. An idea for a plugin. Delay with whatever this was in the feedback loop. It was just a feedback, and it was, I guess, getting encoded in Skype, moving back and forth. So it was getting greedier and
Why can I
greedier.
only hear myself now?
Oh, you're probably hearing yourself via one of the two Skypes. Oh, now you can only hear yourself. Interesting. All right. Is there anything that I can do to... Well, I guess you're not hearing me, but if there's anything I can do to help you figure these technical issues out, then let me know. I guess here's what I'm gonna do. I'm gonna go to the we'll be right back screen. We'll spend a couple minutes trying to fix this, and if we can fix it, great. If we cannot, then we will talk to you more next time. But let's just give a couple minutes and give this a try. Okay, so Alessandro is still figuring out his Skype issues, and Fotis is away. So I will be showing things that I worked on this week, and they're very exciting. So I will be sharing this with you all who are watching, and perhaps later Fotis and Alessandro can catch up. Okay, Alessandro is saying that he is not hearing me, but you all on YouTube are hearing me, so I'm just going to move on to not leave you all waiting. So I said that I would be working on my auto mixer in the C++ version, okay? Not to be confused with what we were working on yesterday. That was JS Effects. I promised that I would be working on the side channel. We can hear you, Alessandro. Okay, I muted Alessandro for now, or while he's figuring his Skype issues out. Anyway, I said that I would be working on this side channel to communicate streams of audio between tracks for my auto mixer to work. I didn't work on that. I worked on something else entirely, and it's very exciting, and I'm looking forward to sharing this with you all. So here's what's up. I got into very beginner stuff, okay, but I got into analog stuff, and here's what I got to get things started. Very simple stuff, and I guess this goes to show that you don't need fancy gear to get started. You don't need an oscilloscope. You don't need I don't know, a lab to get started with these things. So here's what I got. I went to the store and I bought one of these guys. This is a converter. On one side, it is a typical jack that you would plug into a guitar or something. And on the other side, it is this USB thing. So it is very inexpensive, and it is an audio interface of sorts. Well, not really an audio interface, but it's the closest thing. And it is inexpensive, and I don't care about it. So if I blow it up, I don't care. And I guess that's one of my main concerns getting into analog stuff, is blowing things up, blowing up my interface because I sent some signal that was too loud or something, or it was a voltage that was not supposed to get into an interface and I blow it up. If I blow up this guy, I don't care. So another interesting thing, at least for me, sourcing things locally here in Portugal.
Hello all.
Hello, Fotis.
I use a different setup now.
Hello, Fotis. So Alessandro is figuring out his Skype issues, and you are away. So I am sharing the things that I did this week, and then we can have you
hear
all.
me?
Oh, interesting.
Oh.
Can you all hear me now?
Yeah.
Okay. All right. So I'm explaining things that I worked on this week. They have nothing to do with my auto mixer. I got into some prototyping on breadboards and analog stuff, and I'm showing things that I got to get started, starting with this little USB adapter that you can on the other side plug into a guitar. And this is something that is inexpensive, so I don't care about it. If I blow it up, it doesn't matter. So I am feeling safer as I am experimenting. Then, and I am aware that my second camera is like super glitchy. I have no idea why, but at least it is catching up every other second. So, whatever. So I got this, and as I was saying before you joined us, Fotis, it is the weirdest thing. Here in Portugal, it's easy to get jacks if you want to do your own cables, and I wanted to do my own cables because I wanted to plug them into a breadboard. So it's very easy to buy the jacks. It's impossible to buy the cables. For whatever reason, they don't sell cables by just like 2 meters of cable. They don't sell you that. So instead, I had just to buy cables pre-made and cut them. So this is what I did with this one. So I took this one and I cut it in half, and then I put these little plugs at the end that can connect to a breadboard, and I labeled the whole thing. This is so annoying that my camera is glitching this way. So with one side, I can connect this to a breadboard, and on the other side, I can connect this to the computer. And then since I cut the cable in half, I did the same with the other side. So I can plug this into a guitar and plug this into a breadboard. And very simple stuff. I just follow the colors in the cable, and I use the multimeter to find which color corresponded to each part of the plug. So it seems like in this cable, the tip is red, and then the white and the shield in the cable are both the sleeve. And on the other side, same story. So naturally, this is a mono kind of interface. It's a mono signal. And in both sides, the white and the shield, which is the black part, they are both earth. They are both ground. So I also got, where is it? It was right here. Where did I put this? I have a breadboard. It's gone.
Oh my God, everything is going wrong in this stream.
No, it's going all right. Here is the breadboard.
Okay.
So another cable I got, hang on, it is right here. When you start working with these things, the mess that I have in my code sometimes, it becomes a physical mess in my room. It is crazy. So I also did the same thing to another inexpensive cable that is just a regular audio jack. And this is so that I can plug either my guitar with the cable I showed before, or I can plug my computer into the breadboard. And then my computer can be a signal generator. I can generate white noise. I can generate sine waves. And I can put those signals into the breadboard. And
this is a stereo jack.
This is stereo. All right, yes. I'm mostly ignoring one of the channels in this situation, but yes, it is a stereo. And I think that the way I'm doing it is right. The channel that I want to ignore, which is the white channel, which is the right channel, I just set it to earth. I plug both of them to ground, and then I'm just ignoring the signal. I could also, I guess, just leave it floating. It doesn't matter. So in any way, I am saying all this because I can now plug my guitar into the computer via the breadboard, and I can plug any kind of signal generator. And these signal generators can be super expensive if you want to buy a fancy signal generator. But if you're just dealing with audio rate, then you don't need the signal generators with megahertz sine waves and that kind of thing, right? We are talking about 20 hertz to 20 kilohertz. So this seems fine. And I realized that there is a difference in the level of the signal. The computer is generating a signal that is at, I suppose, at headphone level, while my guitar is generating level that is much quieter. So this is something that you need to be aware of when you're doing your circuits. Anyway, so I have some 2 or 3 circuits that I would like to show off because they are the simplest things. And they are things that we have already implemented the digital versions of in my stream in the past. But it wasn't really clear to me how the digital versions came to be. And it seems like they were, of course, transferred from the analog domain. And yeah, let's get to it. So I also have another computer that is not my streaming computer. That is a computer that it is old and relatively inexpensive. So if I blow up the computer, it's okay. So I'm using a completely different system for experimenting with this, just to make sure that I don't blow anything up. And it is true that it is hard to blow things up because we are talking about low voltages and everything. But, you know, I don't want to blow up all the nice stuff that I bought over the years.
Oh, yeah, better be safe than sorry.
Yeah. And all right, so I plugged the headphone into the computer, and I'm going to now plug the tip, which is the green. I'll just plug it here, or perhaps here. I'll do this on the left of the breadboard. Then the ring, which is the right channel, is the white, and the sleeve is the brown, and I'm going to just plug them both to earth. And when I got started doing this, I realized, well, I kind of already knew this, but I confirmed that I am super clumsy. My hands are huge, and I have no ability for working with these small things. But if I have like the right tools and everything, I can get by.
Oh. See, there is a workaround for everything.
Yeah, but I suppose that some people are like coordinated, and I'm not. It is incredible that I haven't blown anything up. And I even have these things here just to hold cables in place in case I bump into something and everything goes floating up in the air. Right, so this is the signal coming in from the computer here on the left of the breadboard. Now let's get our audio interface. Well, it is an audio interface. I don't know why the air quotes. And let's plug that into the breadboard as well. This side, of course, will go into the computer. So I'll just plug that right away. And I'm showing the whole process here because if people want to, like me, get started and they are afraid of blowing things up, they are afraid of this, afraid of that, I hope that this demonstration shows that it's not that difficult. As long as you have some patience and the right tools, you can get by. So yeah, let's have this much of the cable poking out. And I'll plug this in there. And then, all right, so in this case, the chip is the red one. So this is going to be the signal coming in. Get in there. Another reason why I'm demonstrating this whole process is so that people who are very nice in the chat can teach me how to do things better. So if you see me doing something clumsy, let me know. All right, and the two others are ground. So I'm just going to put them in there. All right, so this is supposed to just be a bypass. It's supposed to just transfer the signal through, but it is supposed to be passing through the breadboard. So now let's go to the computer, which is a computer that, I don't really care about. And I'm going to restart Reaper just because when I plug in the headphone and the audio interface, the inputs and outputs change. So I have to come here and configure them again.
Is this Windows 11?
It is.
Wow. It's ironic that you used Windows 11 on a computer you don't care about.
Why do you say that?
I've heard lots of bad things about Windows 11. I don't know
Oh,
about
really?
the permissions and stuff.
I have used it for
they are
2
called,
hours total, so have not run into any issues.
Okay.
And I have, I guess, one issue that I don't know how to solve. So I'm using this ASIO thing, and it is supposed to be the low latency, better thing that you're supposed to use. And for whatever reason, it used to pick up the outputs. It used to pick up my headphone jack as some outputs. And it's no longer doing that. Even though the thing is connected, it's saying that it's disconnected. So I don't know what that is about, but I think that I can always get by with wave out. So I can say that my input is my USB chip thing, and my output is my headphones.
When you installed the Reaper, didn't it install Reaper's own Reaper ASIO? Or ASIO?
Is that a thing? I didn't know that.
Yeah, I think when you install it, it gives you a checkbox.
Oh, really? Well, I installed Reaper via Chocolate, so I don't know.
Oh, okay.
That checkbox will not appear to me, right?
Oh, that's bad.
Okay, so here is something. I have one track that I want to send the audio to my left and right outputs, which are supposed to be the headphones. And I guess my volume is all the way up. So I am supposed to be able to put a tone generator in there. And supposedly audio is going to my breadboard right now. At least it's not coming out of my computer speakers, which was super annoying because it was leading to feedback as I was testing things.
Oh.
And then for the inputs, I can record mono from the left channel. Seems right.
Oh.
I was expecting this to give me some more options. But anyway, signal is coming in. So when I stop this tone generator. The other part goes down as well. But interestingly, it has a bit of noise, which is to be expected because my breadboard is not shielded and it's just a bunch of cables that I wired myself. But it is working. So audio is coming in and out of the breadboard. So fun stuff. With this setup, we can explore a couple secret circuits that I had in mind. So these are the circuits I thought we could explore. So the first is the bypass. That's simple. Then I wanted to show the effect of putting a resistor in the path, and then 2 resistors as a voltage divider. Then the low pass filter and high pass filter that we implemented as digital filters in the stream. And then an overdrive that I put together. Right, so this is the circuit right now. Let's put a resistor in the middle to show what a resistor does.
Maybe you can make a modular synth with this setup. You're very close.
Come on, I have 1 resistor on the breadboard. Let's not get ahead of ourselves. So another thing that I wanted to show was things that I bought because if other people were searching for what they need to buy, and also because if people have better ideas of what I should be buying. But I bought these kits with a bunch of components. They are inexpensive, like this one is €6, and it comes with a bunch of values, and they are not all the values you are ever going to need. But in the case of resistors, for instance, if you don't have the specific value you want, in the overdrive, for instance, I needed 33 or something K, and I didn't have that here. But I had 122 and I had 110, so I just put the 2 in series, and that amounts to the same. So it's a nice thing for you to like get started. Anyway,
It looks very good. What is the K? It's a Kelvin?
No, K is for 1,000. It's like kilograms or kilometers.
Okay. Yeah, okay.
So we are talking about 47,000 ohms.
Oh, whoa, that's a lot of resistance.
Well, not a lot. It's in the middle of the range. So there are resistors that are like 10 ohms. And at least in this kit, and in most schematics I found online, you get up to like 1 mega ohm.
Nice.
So this is like a value in the middle, I would say.
The reason why I mentioned modular synths is because I've seen voltage dividers being used in there.
Oh yeah, we are going to get that in a moment, actually, because a voltage divider is just 2 resistors instead of 1. Okay, so what I'm doing here on the breadboard is I am putting the output on a different lane. The breadboard connects all the columns together. So this column is connected. It's like a shortcut circuit between these 4 pins, or is it 5? 5 pins. And then now I'm connecting this to different columns. So now the input and output are disconnected. In fact, I can show you this here in Reaper. Now the signal is coming out, but it's not coming back in. And when I touch the cable, you can see the volume going up. And that's because when I touch the cable, it makes that bzzz sound that you get when things are not wired properly. And in the beginning, I was like powering everything off and then doing the changes and then powering everything back on. And I was like, oh, this is going to blow up. And then at some point, I'm not disconnecting anything. I am just putting stuff on the breadboard and putting my fingers on the circuit. It's much safer than other projects out there. And I realized that my camera is just stuck. So I'm going to restart.
It's frozen, yeah.
Going to restart the camera real quick. And my phone is getting super hot. My second camera is my phone. So perhaps it is that is the issue. My phone is like breaking up.
Are you using it to watch the chat as well?
No, I am not watching the chat right now. So if you are, and people are saying interesting things, then
I'm gonna check it
know.
right now.
But this is something I want to say when I'm like interviewing someone and I'm focused on the conversation. I may not be reading every message on the chat, but when I finish the stream, I always read what people wrote. And in some cases, it's annoying because I read what people wrote and I feel like I want to reply, but there is no easy way for me to reply. There is no easy way for me to get in touch with someone. There is no link to their channel. There is no email, no nothing. And sometimes I have to stalk people on like Twitter to find a way to get to them.
The most annoying thing about the YouTube chat is that you cannot even visit a person's profile by clicking on their name or their avatar.
Yeah.
Oh, by the way, Tail is saying on the chat, please add an oscilloscope in Reaper so we can see the signal.
Fair, I will do that in a moment. As soon as I can get my second camera going again. It's saying that it's connected. Over here in OBS, it sees the camera.
Oh, and Bo and a person called M9 are talking about the circuits, about the plastic tweezers, or he says, Leandro, soon you'll be mapping transfer of different germanium diodes and looking at the ripple signature of paper in oil versus polypropylene capacitors.
Yeah, I was looking at some diodes that are more difficult to find and where to order them from. And it's not that hard to find some good diodes, but they may not have the magic qualities of the Clone Centaur diodes. But anyway, come on, will I have to give up on this? Oh no, it's back, it's back. You just restart the whole thing 15 times and then it works. Great. Hang on. Click here, click there, and we are back. But now we are in the wrong orientation. Can I change this to horizontal? There you go. Excellent. And of course, it's still glitchy, but it is there. So connecting the diode, the resistor this way, bridging the gap between the two columns, we put the resistor on the path of the audio. Now the audio is going through that resistor. And what do you expect this to do? Any clues?
It's just a high-pass filter.
Yeah, okay. So we have one high-pass filter. Fotis, what's your guess?
I don't know. Is it splitting the voltages?
It is doing that to some extent, yes. So when you pass some signal through a resistor, part of that, the signal is voltage, right? It's electricity, it's voltage. And the voltage represents the position of the speaker cone over time, right? It is an analog of the sound waves, hence analog, right?
Oh.
And that's, it's an analogy. Electricity is an analogy of the air pressure. So when you put a resistor on the path of the audio, what happens is some of that electricity is dissipated in the form of heat. So what we see is some attenuation. Let me show you here in Reaper. So this is the signal coming out of the headphone jack and the signal going into the audio interface. And you can see that the level dropped. And let me take a moment here to try to bring Alessandro back. Yes, he's back. So now I also put here an oscilloscope as well as a frequency spectrum analyzer. And we can see the frequency of the sine wave I'm sending out. That's this huge peak. We can see a lot of noise. And this is the shape of the wave. So here on the breadboard, I can put the... perhaps I'll do this because I didn't do it when I was bypassing. On the breadboard, I'm putting the output back into bypass.
Can you please move those windows to the left, because on the right it's
fair.
us.
Yeah, so here I am putting the thing back on bypass so we can see the thing on the oscilloscope. And let me change the windows. You are absolutely right. So I will want to have this window here, that window there, and this window there. And I don't need that window.
Well, I guess this window can be a bit bigger, but not too big. This is perfect.
Oh, it's good. Yeah, very good.
Yeah, so when the thing is just going straight through, we see a sine wave. We also see this small bump here in volume. It's about 3 dB, and I have no idea why. I think either the cheap interface or the cheap digital to analog converter on the headphone jack, one of these two are adding 3 dB of gain. So whatever. And then when I put the resistor in the path, then the signal goes down in level. Interesting, huh? So that's just a simple resistor. Now, let's get to a voltage divider, which is also resistors, just 2 of them in a row. And to make things even nicer, here is a trim pot. It is... Is my camera stuck again? It seems like it's not updating enough.
Yeah.
Come on. Will I
Now
have
it's
to
gone.
restart everything 3 times again? I don't know. This is a trim pot. It is just like a knob that you have in any kind of gear, except that it's very small and I can put it on the breadboard. And while I'm restarting the camera, I will also be putting this on the path of the signal. Oh, I think I have to unplug and replug, but I don't need to restart the app. All right, it seems like we are back. And I'm not...
Yeah.
I want to turn this sideways. I guess the best way to do that is this. Okay.
Oh, nice.
So I said that this is like 2 resistors in a row, and the arrangement, as far as I understand, is this. There is these 2 pins, and they are like the 2 ends of the 2 resistors. And this tapping in the middle is in between the 2 resistors. And because this is a potentiometer, I can turn the potentiometer like you would turn a knob, and the resistance would be more on this side or more on that side. As I turn things clockwise, there will be more signal going through these 2 pins. So the resistance will be more on these 2 pins. Does that make sense?
Yeah.
Okay. So to put this in the path of the signal, I am going to put it right here. There it is. And then on the leg in the middle, just for demonstration, I will put the leg in the middle. I will put that as the output. And that's not a voltage divider yet. That is just a resistor, just like before, but it's a variable resistor this time. So I can take this, and I can turn the potentiometer so it will vary its resistance when I turn it. Let's see what that does to the signal. So we already know that resistance is going to lower the level of the signal. So as I turn, you can see the signal going down.
Oh, yeah.
Now I'm
it's
turning back.
going back up.
Yeah, I just turned it back. So next, let me do a different arrangement. I will keep the signal here in the middle, but I'm going to bridge the gap between
the
the
camera
second...
froze again.
Oh, did it? Okay.
Oh no.
Now I know what to do. It's supposed to be back.
Oh,
It's back. So right now, I said that there are 2 resistors in this little component, and there are, but we are just using one of them. You can think of this as 2 resistors like this, and we are only using the one on the left. The one on the right is not in the circuit. Now let's put the right one in the circuit just by connecting the right leg of this little potentiometer to ground. What that will do is it will put the second resistor in the circuit, and there will be another path for electrons to go through. Let me focus on this. And because there will be another path for electrons to go through, the signal will go even lower. The effect will be the same. We'll just be able to lower the signal. So this is like a volume knob that never adds gain. You can only attenuate. But now it will be able to attenuate even more. So I'm going to take in the potentiometer, and I'm going to turn it, and we can see the results here on the signal. And as I turn this, it is going down, but it can go down much, much lower than it used to. Before it was getting to like around -30, and now it can get down to -60. Because there is this other path for electrons to go through. So that is a voltage divider, which is a simple volume knob that can only go down. Cool, huh?
Basically, you created a voltage amplifier.
No, I'm not amplifying anything.
No.
I am only
No.
attenuating.
Attenuator. Sorry, you created an attenuator here.
Yeah, and this is the kind of thing, when I get to the final circuit, that is the overdrive pedal, this is what is used for the volume knob. So for people who are guitarists, overdrives usually have like 3 knobs. The most common overdrives have 3 knobs. There is a gain on the way in, and that is amplification. So that's not what this is. Then there is usually some tone control, that is the low-pass filter that we are about to look at, or some variation thereof. And then there is a volume knob. The volume knob is just taking the output of the circuit and attenuating it. So this little potentiometer is working just like a volume knob on an overdrive pedal.
Nice.
Right. Next, I know that anytime I switch from Reaper to my bench, I have to replug the cable. Isn't that great? And so what's next is a low-pass filter. And we have covered the analog low-pass filters, and we have even explained how they work in our previous streams with Dale. So people who are interested in more of the theory can go watch that. But I'm going to briefly explain how that works. So the setup is similar. The audio comes in, and it goes through this resistor. Come on, get in there. But this time it does not go straight to the output. Before it goes to the output, we go through a capacitor. And I have a bunch here that I bought. It was another one of those kits. And I also bought some special ones that I needed for the overdrive schematic. Let's see. I think that when we had Tail over, we used a capacitor in the circuit that was 10 nanofarads. Was that? I don't remember. Yeah, but let's try 10 nanofarads. That should do. That should work. Let's see. So if a resistor is just dissipating electricity as heat, so it is lowering the signal, and you can think of perhaps the water analogy. A resistor is like a pipe that is just a bit narrower, so water goes through the pipe with more pressure. Following with that analogy, a capacitor is just like a small tank where electrons can accumulate. And when you are pouring electrons into the capacitor, it is going to charge. And when you stop pouring electrons into the capacitor, it's going to discharge. So it is just like a tank of water that you can pour water into, or you can get water out of, as long as there is some pipe for the water to go through.
Oh, by the way, you can emulate this behavior with the Air Windows Capacitor 2 plugin, which has an analog modeling of capacitors, and if you overdrive it, it has a fader called nonlinear. It turns it into a nonlinear EQ of sorts. And
Interesting.
it's like what you said about the water. It's actually overstuffing the capacitor, and it sounds distorted.
Interesting. Yeah, so we are not overdriving the capacitor, right? But the capacitor still is going to store energy and give it back to us. And when we are modeling this in software, we typically think of capacitors as like some sort of memory, because it remembers if it was charged or not in the past, or some kind of state of sorts. Right, so what I'm going to do with this capacitor on the breadboard is exactly what we had on the other stream in the Wikipedia article and the schematic and everything. I'm just going to put this right here in the middle of the potentiometer. So now the signal is coming in to the left of the potentiometer, and the signal is coming out of the middle leg. So we are introducing a resistor here in this path. So this middle leg is connected to the left leg of this capacitor and getting into this other row that is unused at this point. So the capacitor is just floating in the air right now. Let's connect this capacitor to ground by putting one leg of this little jumper cable here. I probably could have been smart and just bend the legs of the capacitor to reach across to the negative, to this lane here, but I didn't. So now I'll use a jumper cable instead. And this is going to be a low-pass filter. I'm going to briefly explain the logic behind this. It's going to be a low-pass filter because when some audio that has high frequencies is going through the circuit, the high frequencies will be accumulated here on this capacitor, and they will be played back, so to speak. This is my intuitive explanation. It may not be the most technically appropriate one, but it is how I understand things. So these high frequencies will be charging the capacitor while they pass through, and when they have passed, the capacitor will give back this energy to the system. So in other words, the high frequency wants to go through, but the capacitor is sort of compensating for the high frequency. So when the high frequency stops going through, the capacitor is going to still give some energy. So it's going to, if you think of like a square wave that dips down immediately, the capacitor is going to take a bit of time to discharge. So instead of being a square wave, it will be more like a round shape around the edge. And in other words, that is taking out the high frequencies, some of them anyway. And then we are tapping the circuit right here in the middle, not on this right leg of the capacitor that is going to ground. So that's always 0. If we put the probe in there, we'll be just be collecting a bunch of zeros or noise, I guess, because in analog there is always the issue of noise. So yeah, when I put this leg here on the right of the capacitor, over here in Reaper, we can see that there is no signal. But if I tap in the middle, it took me like 2 hours or more, I guess, probably more, like 3 to 4 hours to make all these little cables with this little heat shrink sleeves. And because when I cut them, they were like these kinds of cables that have 1,000 little filaments, and I wanted to be able to put them in the breadboard easily. So I put this heat shrink thing and I put this rigid cable on the end. That took me so much time to do. And now watching this, I
Sorry.
guess you can see why, right? Because I
Yeah,
shape so much.
I had a random disconnect. Can you hear me now? I'm back.
Yes, we hear you.
Okay.
Okay, so the cable is in there again. Let's put the potentiometer back because it popped out. I really wish I had better potentiometers that would stick to the breadboard more. These that have the tendency of jumping. Right, so for this test, it doesn't really make sense to use a sine wave. Let's instead use some white noise. Okay, so now white noise is coming through. It is a flat shape as we expect. And as I turn this potentiometer, we start to see a slope. So I don't think that my potentiometer is the best to showcase this because the slope just immediately appears and it doesn't really go away. But we can see a slope. We can see that the lower frequencies are higher in gain while the high frequencies are lower in gain. And if I am like on one side of the potentiometer all the way counterclockwise and I move ever so slightly, you can sort of see that low pass filter shape coming about. See that? And this is this is a first order low pass filter. So the slope is just 6 dB per octave, which is not super steep. And also the values of resistor and capacitor may not be ideal to do this kind of filter, but those are the components I had. So that's what we are going with.
Yeah, it seems to function. It's low passing.
Yeah. And I can also put slope here to prove that it is around 6 dB. So when I put a slope of 6 dB per octave, it looks flat again. So we can be sure that the slope really is 6 dB per octave.
Yeah.
Now, the next and second to last component circuit that I would like to show is the high pass filter, and it's very similar to this circuit, except that you swap the roles of the resistor and capacitor. That's all you do. So let's try to get this in the circuit. That guy is there. And this one.
Are you safe from DC offset?
Well, the truth of the matter is, first of all, it seems like I was able to go to Reaper and back into my secondary camera without the disconnect. So yay. But yeah, it seems like I tested this by creating a sine wave in Reaper and just bypassing the circuit like I did in the beginning. And I put a DC offset in Reaper as an effect. So the sine wave going out had a DC offset, and when I read it back, it didn't have a DC offset. So some part of the system is filtering out DC offsets. I don't know if it is my audio interface going out, my digital to analog converter on the headphone jack, or if it is the little cheap interface. So yeah, that's a limitation. If your circuit has some DC offset and you may not be aware of that because, or in my case, in my specific scenario, there is this limitation where I don't know if some part of my circuit is introducing a DC offset. So yeah, perhaps it is worth spending $400 on a low-end oscilloscope, but just for that issue, I am not forking $400 right now.
Yeah, you can always use the JSFX. That there is a great fork, a different version of the DC offset filter. It's not on Repack. It's by a person called Chokehold on GitHub.
Yeah, I know.
And the difference between that and the regular DC offset filter is that it can work in multi-channel.
Oh, I also have one of those in my repository, a multi-channel DC offset thing. I programmed it live on a old video of mine about 2 years ago. So I'm looking at this and it seems to be okay. So signal is coming in into the first row. This capacitor is connecting rows 1 and 2. Then the resistor is going from rows 2 and 3, and the signal is coming out. So I'm tapping in between these two components, and then the right leg of the potentiometer is going to ground. So this is... Oh, actually, I don't want to use the right leg of the potentiometer. I want to use the middle leg of the potentiometer. And I want to tap into the left. Yeah, this is incorrect. Let me fix it. There it is. Okay, so now the output is coming from the right leg of the capacitor and the left leg of the potentiometer, and the middle leg of the potentiometer is going to ground. So we are only using one of the resistors in the potentiometer. We are using it as a rheostat. We are just using it as a resistor that we can easily change the value of. We are not using it as a variable, as a voltage divider. All right, so that's what we have right now. Let's see what we get. Oh, this is not in the board, is it? Oh, it is. Okay. Yeah, as I say, this guy keeps popping up, but it seems to be in the board. So right now we have no slope, so the signal is just going through. It is white noise. This is perhaps too lowing level, and is still the white noise that is coming out. Hang on. Yeah, this is the white noise that we are producing. It's not just white noise from the environment. So as I turn this pot now,
the high pass.
It is a high pass.
It's high passing. Very sadly, but it's high passing.
Yeah,
wow.
Now it's not so subtle anymore. Yeah, again, it is just on one side of the potentiometer, so perhaps this is not the best value of potentiometer. This is 100 kilo ohms. Maybe not, and I'm using the 10 nanofarad capacitor. So this may not be the ideal components for this experiment, but check this out. It is, for sure, taking the low frequencies and cutting them out. And the intuitive explanation I have for why this circuit works is it is sort of like the opposite of a high-pass filter. If you just take the high-pass filter and invert the positions of the components, you are supposed to get the low frequencies that you cut, or you're cutting the low frequencies that were passing on the other circuit. And you can see values going up and down. That's because my potentiometer is popping out of the breadboard. It is in now. So you can definitely see a slope here. Let's measure and see if it is 6 dB. Oh, this doesn't go negative. And I don't have other spectrum analyzers installed here on this machine. That's too bad.
Oh, yeah.
But let's trust that this is a 6 dB per octave slope. So yeah, that's the second to last little circuit. And the last circuit is really just a shout out to the YouTube channel that inspired me to actually go to the store and buy all this stuff. And it is a relatively new and relatively small YouTube channel. Let me get the name of the person right. Hang on. How do I see my subscriptions on YouTube? Okay.
It's on the lower left, I think.
Yeah, but my screen is somewhat smaller, so it wasn't showing up. So yeah, Arito Suzuki is this YouTuber from Japan, and he is a relatively small channel, but it was promoted by Aaron from the Lanterntronics channel, Aaron Lanterman. He did a video promoting this channel, and it is really a great channel. So he does all sorts of tests on different kinds of op amps, and he started this series of building an overdrive into a breadboard. And it was right at the level I needed for my understanding. And another great thing is that unlike most YouTubers, this person is not in the US. So when he is telling you like go buy this part or that part, he gives you a bunch of alternatives, things that are available in Japan and incidentally also available here in Portugal. So it was much easier for me to just build this circuit because I didn't have to translate components. And it can be annoying when you see a component, or maybe you see a circuit with 10 components and just this one is the magic component that only is easy to find in the US. But no, he gives you like 3 or 4 options for each component that needs to be exchangeable, like an op-amp. And I was able to find everything locally. It was great. And then on the second video from 5 days ago, he shows you step by step what you need to do to turn a schematic into something on the breadboard, which may seem straightforward, and it is not super difficult. But it is a skill because you have to find the place for all the components, and sometimes you have to use tricks like putting 2 resistors in a row because you don't have the right resistor, or putting 2 capacitors in parallel because you don't have the right capacitor. And he talks about all these little details that go into actually making something. And for people like me who were just experimenting with watching other people and experimenting with LT Spice, going into a breadboard and doing stuff is great. So by following his 2 videos as well as watching a bunch of other ones, I was able to come up with this. So this is, oh, come on. The camera is going to freeze now. Get back. Hey, there you go. So this is an overdrive pedal. It is similar to a tube screamer, not quite exactly the same circuit. It was, as far as I can tell, an original design, but it is definitely inspired. But I think it was Arito's design, but it was definitely inspired by the tube screamer. And you can even see the little clipping diodes. They are just regular diodes. They're not germanium diodes. They're not magical diodes, but you can see the 2 clipping diodes. And you can see this potentiometer acting as a volume knob at the end. So this is working as a voltage divider. On the left is the out. On the left, I'm connecting this to ground. In the middle, I tap to get the signal. And on the right is this huge capacitor. I couldn't find a capacitor that was for low voltages, so I bought a huge capacitor for high voltages. Anyway, it's feeding the signal here. So there is the whole circuit. And then as the final step, this potentiometer works as the volume knob. And we can also see, well, I guess this capacitor along with this resistor is working as a filter, right? As we just saw. So when you put a capacitor and a resistor, you have a filter. And similarly, there is a filter here, and that's your tone control. So this is the resistor and this is the capacitor connecting to ground. So that forms a low pass filter for the tone control. And then there is the clipping diodes that we didn't get into, the op amp we didn't get into. So if you're interested in this kind of thing and you want to learn more, again, go to Arito's channel because it is great. I know this was a super long update, but it is because I'm so excited to actually get my hands dirty. It's the perfect mix of doing something very nerdy, but something that is tangible and physical and working with your hands. So it's very rewarding, very fun stuff. And I recommend that if you can, go ahead and do this. It's not an expensive setup to get started. You can definitely do this project and much more without spending a lot. And you learn a lot and you see stuff that people talk about and you put your hands on things, and if you're lucky, you don't blow anything up. Lots of fun. So that's my update. So Alessandro, did you figure out these issues you were having?
Hello?
Hello. Yeah, we can hear you.
Okay, I'm using the webcam microphone now.
Okay.
Yeah, it sounds louder.
Yeah, it does.
Okay. Let me check screen share.
Oh, yeah. Okay, so I just want to answer
Can you
one
see
question
my
from
screen?
M9 asking, how does the overdrive pedal sound? You can go to Arito's channel and check out his demonstration. He does a full demonstration of the sounds and all the knobs and everything. And mine sounds exactly like his because it is exactly the same circuit with almost the same parts. So, of course, there is always variance in the components and everything, but it sounds very similar. And I already talked for about an hour, so I didn't want to do another 10 minutes of me connecting the guitar and everything to demonstrate this. But it does sound very good. It is a relatively straightforward circuit. It's about like what, 10 components? But it is something that I would definitely use. I actually played around with it for like 1 hour after I finished building it because it's such fun to... It is my first pedal too. I never bought a pedal. I always used emulations on software. So it was the first time I could actually turn knobs, physical knobs. It was great. And it sounds amazing,
Nice.
actually. I really like the sound of this. I am no like pro guitarists, and I don't know a lot about finding the perfect tone and the magical diodes. I can really hear the difference. I'm not that person. So to my ears, as my first pedal, I love it. I may even get an enclosure for this. I don't know. For now, it's just an experiment, kind of a prototype. I still want to be able to poke around and peek into different parts of the circuit to see what all the filters are doing exactly, but I didn't get to that. But yeah, it sounds great. Go to Arito's channel and hear his demos, and you hear for yourself.
I subscribed.
Yeah, great. All right, so we see your screen, we see your camera, and we hear you. So tell us
Great.
about this time stretcher.
Okay, as I said, sometimes it's just a program that can load an audio file, and then you can slow the audio down to some extent. And I'm using this paper as a base for the time stretching algorithms. And in this one, they discuss different approaches to time stretching and explain them. And I'm not sure if I just should.
Do you know how it compares? So when people talk about time stretching, one of the most famous open source implementations is PostStretch. And I guess now there is also the Reaper implementation of time stretching. So how does this paper and your project compare to these other implementations, if you know of them?
I mean, I know PostStretch, the name. I'm not sure how it is implemented, and they don't mention it in this paper.
Fair.
And they talk about like 3 different time stretching approaches. And one of them might be the one PostStretch uses. I don't know.
If you want, I can post in the chat a GitHub repo for a fork of PostStretch, so you can see what it does and how.
Okay. Yeah. And so far, I only implemented the basic overlap add algorithm, which is like a schematic they have here of this one, which is just you divide the audio signal into small windows that overlap each other.
Oh, yeah.
And then every window gets like a windowing function to reduce artifacts
Yeah, it mirrors them.
And then you like add them on each other to get like the new audio signal. In this case, it doesn't stretch, it does the opposite, so it speeds it up. And yeah, that's basically what I'm doing right now. And I'm not sure I got all my code on GitHub for now. And like,
so you just implemented the paper, right?
Basically, yes, but only like the very basic part of it.
Okay.
Like
there is a great explanation of this idea of using overlap add and just deciding that the steps on the analysis are different from the steps on the synthesis. So if you just take the different steps on the analysis and synthesis, you are either stretching time or compressing time. And there is a great explanation of this in the book that we started following in the beginning of the study group. It is the Will Perkle book on audio effects in C++, something. So there is a chapter that is not really about C++, it's more about the digital signal processing kind of things. And it explains this very well. I don't know this paper, it may be an even better explanation, but I just wanted to throw this out there because that's how I learned about this overlap at algorithm when it comes to time stretching. Perhaps even Will Perkle was citing this paper, I don't know.
Probably not. I think the book is older than this paper.
Oh.
Yeah, and then like they have some more advanced ones where they like analyze the signal before they compose it. So and then you have like slight offsets in the window, so you can get signals that correlate better to each other. Which is like the one I want to do next, which is like the overlap add, but a little bit more advanced.
And
Yeah.
can you show us the software working?
Yes. Hope I did not delete the build. Where do I have it?
While you're looking for it, I just want to add one more thing that I forgot to say. M9 asked how it sounded, the overdrive sounded. There is one thing that I really liked about the sound of this, and it's something that Arito didn't show in his demonstration. So I was running the circuit, and I took the power out. All the circuits I showed here on the demonstration, they were all passive. They didn't have any other external source of electricity, right? But in the overdrive, you need a 9-volt battery. And if you're playing through the thing and you take the battery out, the circuit starts dying. And it sounds amazing. I loved that. And in fact, I don't have a 9-volt battery. I bought this regulated adapter power voltage something. And I did to it the same thing I did to the audio cables. I just cut one end of it and plug it on the breadboard. And this thing allows me to get 9 volts or up to 12 if I want. And the cool thing is that I can turn this on and off with a knob. And that means that I can like change the sound of the circuit by giving it less energy. And I perhaps can even give it more energy, but I think that then some components may blow up, and I don't want that. But yeah, when it comes to the sound, one cool thing is just play the circuit and it's not that I unplug the battery, right? I think that if I just unplug a battery, then the capacitors will discharge and they will go to silence relatively quickly. But this power adapter is plugged into the wall, and I believe it introduces some noise because of that, but never mind it. I didn't hear anything significant. And it does have the advantage of lowering the voltage, and you can just like pretend that you have a battery that is old, or you can just turn off the circuit and it will discharge over time, and it will sound amazing, and it's a cool trick. Yeah, sorry to interrupt you. Show us the transcriber.
Okay, this is the UI for now, which is basically the audio player example from JUCE. And so it just has like a simple open button, and then it enables the play and stop buttons. And this is where you can change the window size. And this is for changing the stretch value. So bringing it lower makes it play slower. And I'm not sure of. I guess this is not giving audio.
We don't hear that. Perhaps you don't have the computer audio routing into Skype.
Yeah, let me. Okay. Does it work now?
No.
Oh. Okay. working?
Yes.
Okay, great. So this is what it sounds, not slowed down. And like this should be slowed down by 10%. Yeah, so far doesn't sound very good, but it seems to at least stretch the audio signal.
What do you think you don't like about this?
I mean, there is really noticeable artifacts.
I hear clicks in the middle, and I think I also heard sometimes where it kind of skipped.
Yeah, just like sometimes it doubles some things, which I guess is when the windows overlap wrongly, and so it doubles some stuff.
And do you think that these are problems with the original algorithm, or are they problems with the implementation you have?
I think it's a problem with the algorithm in itself. Yeah, that's why the next thing I want to do is implement the more advanced algorithms that account for these problems.
I see. Do you know what would be causing the clicks? Because the skips you just talked about, but the clicks, they seem to be perhaps they have to do with the length of the window?
Yeah, wait, they have a schematic for that. It's because when you, can you see it on screen?
Yeah.
Yeah.
Can I paint or something? Probably not. Oh, okay, if you have, like, the top is the regular audio signal in this image, and the bottom is the stretched one. And if you cut it into pieces and rearrange those pieces, the signal might not align perfectly. And that's when those clicks happen, which is like in the bottom schematic where the blue circle is.
I thought that the purpose of the windows when you take a segment and you apply a window was exactly to fix this kind of discontinuities.
It fixes it a little bit, I think, but in some cases there might still be discontinuation and clicks happening.
I see, interesting. And how do you plan on fixing that one?
That's the next algorithm. It's the, where does it say? I don't know what it is. But what they basically do is, there it is. If you do decide on your next window for your analysis, for your next frame, you do an autocorrelation function and find a window that's very similar to the first window. And so you try to find a window that when you move it around to the next spot, that does not have these clicks or this discontinuities.
It's doing smooth fading in between the windows, right?
Yeah.
I think a similar thing happens with pole stretch. It takes extremely small bits of audio and then it smears them with smooth fading. Kind of how basic reverb works.
Yeah. So what I do is like you have one frame and the next frame you don't do it in, like, for example, not in 1024 samples, but you also check in a range if one of the other frames that's not exactly at 1024 fits better. and then you have like a range of possible frames, and you see which one has the lowest amount of discontinuity.
Mhm.
And then you try to minimize the discontinuities like that. Basically, like, well, that's the problem.
Ah, okay. That
Yeah.
makes sense. So it's that kind of paper where they start with the most straightforward but perhaps too naive approach and then build up. And now they're using the window in the way that I was thinking about.
Yes, and the next step then is like a phase vocoder to get better phase alignment. So then they implement the phase vocoder and try to get the phases right of the signals. That's where I kind of stopped reading. And then they do some really advanced stuff where they split the signal in harmonic and percussive
nice.
separation. And then you do two different kinds of time stretching, because one kind of time stretching works better for percussive signals, and one kind of time stretching works better for harmonic signals. And then you split it up, do those different kinds of time stretching on the signals, and then you combine it again.
Yeah, one of the algorithms in Reaper, the time stretching called the rubber band library, it gives you the option of either focusing on tonal sounds, on percussive sounds, or mixed signal.
Yeah, so it probably does something like that as well. Yeah, so this is the schematic. So they split it up, then do the overlap add for the percussive signals and the phase vocoder time stretch for the harmonic component, and then they combine it back again. And yeah, that's what they do in this. Like, I know this author, Meinert Müller, who wrote a book on music information retrieval, and I did a masterclass with him once, and it's like what I do a lot in this book. Like,
oh, nice.
Yes, but I'm like really at the beginning. It's like really simply UI, only one algorithm. Yeah, and the last few days I spent mostly refactoring the code and moving away from the producer and using CMake so I can easier automate it and use CMake to build stuff.
Why do you want to automate? Do you plan on building this on some continuous integration server or something like that?
Yes, that's actually what I did. I did like link my GitHub to AppWeyer.
Oh, AppWeyer, yeah.
Yeah. And like now it automatically builds every time.
Awesome.
By the way, now you can do it with GitHub Actions as well.
Yeah.
I don't know if it works the same way, but yeah.
I need to look into that. Yeah, that cost me like a few days now.
And why do you want to automate the build on a continuous integration server?
Mostly just for fun, because I never did stuff like that. So I was curious how stuff like that worked. Yeah, I also want to add some testing and stuff just to have done it out of curiosity.
Right. And Bo has a question for you that I also have. Do you have some highlights either in the code or on this continuous integration configuration, some part of the implementation that you would like to talk about?
So far I can explain maybe how I do the DSP stuff. I yoinked it from some video about the phase vocoder for the Bella chips mini computer, which where I basically have two buffers, one input buffer, one output buffer. And then first I put everything into my input buffer. And then once I have enough samples collected for one analysis frame, then I do the whole DSP, which for now is only doing a Fourier transform and doing the reverse, and then I put it into the output.
And for the FFT, are you using the lightweight FFT implementation that comes with JUCE, or are you using some FFTW or some other library?
I'm using some other FFT
Okay.
algorithm, which is just called audio FFT, which is some FFT implementation mainly focused for audio, so it's has no super complicated interface. So it's just a few simple FFT functions.
Nice.
Yeah.
Well done.
So most of the
implemented
overlap algorithm came from this other implementation you were talking about, this Bella implementation.
No, that was for a Facebook coder. But
okay.
because I plan to implement a Facebook coder, but for now I only did the basic overlap add algorithm. But I did the double buffer thing. I did from the Bella implementation for a Facebook coder.
Oh, Facebook coder. Okay.
Yeah, then I also did the implementation of a STD vector, but for complex numbers. I'm not sure why I did that.
Okay.
Yeah, because the regular vectors, I think you can't get a pointer to something. Yeah.
And what is the final project you have in mind? Is this going to be a standalone program? Is this going to be a plugin you load into a DAW?
It's going to be a standalone program, because it's like similar to the transcriber program that already exists, which is like commercial transcribing software for music. Yeah, and I want to have like my own version of that, basically.
And the idea is that when you slow things down, it becomes easier to transcribe because you are listening in lower range.
I want to make it easier to listen to and transcribe stuff. And yeah, in the end, I also like the empty room should be like some space where you see the waveform or something, or a timeline, and then you can add notes to stuff.
Of course.
Yeah, so you can make annotations, like write down harmonies or something you hear, so you have everything.
And I guess
in
your
one
final
window.
goal is different from something like post-stretch or because your goal is to make the song listenable and understandable, while these other algorithms are more going for effect. So they sound like reverby versions of the original, not closer and trying to be more faithful to the original signal.
Yeah, I want to introduce as little artifacts as possible, so you can hear the actual notes that are played, or the rhythm and stuff, so you can transcribe a song. And
Nice.
It's not really meant to as like an instrument or something.
Okay. And what do you think is like one tangible next step you can promise, but maybe not deliver? I didn't deliver my promise from last meeting, but what is one step that you think you can take for the next meeting?
I want to implement the next step of the overlap add algorithm. That's like based on waveform similarity. I'm not sure if I can do that until next week because I'm gone until Sunday.
Okay.
Yeah, and or maybe what I want to do, like for now, I have all my DSP in the get next audio block function, but I want to refactor it and just have like a class that has like a process function, and then I put in the audio buffer and it does everything for me.
Nice. I appreciate some automated tests. Just keep in mind that we don't meet every week, okay? We meet every other week. So you have more time.
Then I got time.
Bi-weekly.
Yep.
Okay, then I should probably be able to get some stuff done.
Great.
Yeah. And M9 here on the chat has a nice idea. You could have some kinds of filters, high pass, low pass filters, or maybe even fancier EQ filters to focus on some sound. So perhaps you're transcribing the bass, you do a low pass, or you are transcribing this other instrument, you would do some band pass.
Yeah, that makes sense. That's a good idea to keep in mind. Once I got a good bass working, so I can have, it makes sense, because different instruments are in different ranges on the spectrum.
Yeah, and your filter doesn't need to be anything fancy, because it will not be automated, it will not be nothing crazy, so it can be very straightforward filters like the ones we have implemented in this channel before.
Yeah. That's a good idea to have like a filter section or a DSP section to enhance the audio signal, to make it more easy to listen to specific things.
All right. So any other comments before we move on to Fotis's update?
No, I think I got everything covered for now.
All right. Thank you very much for sharing all this, by the way. And Fotis, take it away.
Yeah, I'm going to share my screen with audio. And it should work, right? Using a screenshot.
We see stuff, yes.
Yeah, this happened just after we began our talk. I got a response to a private message I sent on the GitHub forums to this person, RC Jack. Do you know this person? They run Repack. They're making JSFX.
Okay, yeah, so, I have seen this name before.
Yeah, so this person is making various useful scripts, and one of them is a fork, if you will, of the Air Windows bit shift gain. The reason why I'm saying that is the same way Chris is saying that. Remember, because YouTube thinks that you're cursing.
Yep.
Bit shift, yeah. Anyway, so I did. This is the fork that RC Jack created. That's called RC Every Gain. It's JSFX, and it combines three Air Windows plugins: the bit shift, which is adding or removing increments of 6.0 to 0.6 decibels; the purest gain, which is a smoother fader; and the every trim, which allows you to make adjustments to the mid, the side, the left, the right, etc. But as you can see here, I did an experiment. I played audio and I used first two instances of bit shift gain. The one is removing 1 bit and the other is adding 1 bit. And you can see on the frequency, the spectrum analyzer, that it's completely nulling when played with a second track that plays the same audio untouched. But when I did the same test with the JSFX version, it creates some kind of noise here in the noise floor. So I contacted RC Jack about it, and they had this to say. They replicated the error, and they can confirm it, but they said that it's not something to worry about. And they concluded that JSFX adds a low-end bump when processing audio, a static bump around minus 300 decibels below 80 hertz. I just said it's just so you know, because you are making JSFX, that if you see this kind of behavior, it's something to keep in mind.
I think I know what's causing this.
Mm-hmm.
It's a conversation that Tail and I had. I was asking him back and forth 1,000 times about this, and it seems to do, I think, with the protection that JSFX has in place against denormalized numbers.
Oh,
Yeah, so denormalized numbers are these very small numbers that you cannot hear, but if you are doing arithmetic, the computer doesn't know that it's a small number, so you don't hear it, and it just faithfully computes the correct outputs, correct up to the error, of course. But it tries to compute this arithmetic on these small numbers, and the protection that Reaper has for this is it adds very small numbers to the inputs, and these small numbers are still not something you can hear, but they don't cause these denormalized numbers to show up. Denormalized numbers are very, very small numbers, and Reaper adds very small numbers, not very, very small. And
yeah,
and
makes
that
sense.
can be it can manifest itself as I guess DC offset depending on how you're using samples. It can also manifest as some like a sine wave or a square wave at half of the sampling rate, because they add numbers that go up and down. It's not a random number, it's just a very small number, very small negative number, very small number, very small negative number. And this means that it will not necessarily be bit transparent, so to speak. It's not necessarily going to be exactly the same as a VST implementation that may or may not be dealing with the normalized numbers, and it may be dealing with them in a different way. So that may explain things, but I don't know. Probably Tail is going to show up in the chat and correct me again.
Okay, I just wanted to... Now, before I move on to my actual update, I wanted to say a little story. My godfather had a revelation, which is going to be a great transition from your breadboard, because he used to experiment with audio technology, and it was around, I think, the 80s. It was the very first time he listened to stereo audio, because he had bought a new pair of headphones, and he realized that the cable had actually two audio inputs and one that was the ground. Usually in mono it's only the audio cable, the audio wire, and the ground. So he said, "What's going on here?" And then he listened to stereo and he was floored. So, but this is 2022 and we have moved on from stereo. And I got this thing. This is a free trial, but oh, by the way, I did have 2 random disconnects earlier. So if I disappear, just please bear with me, and in 3 minutes I will be back. Anyway, so this is a free trial, and fortunately it's not one of those free trials that emit noise or stop the audio every 5 minutes. The only limitation is that it will stop working after 2 weeks. But this is a virtual surround application that is based on the studio of Alan Meyerson, who is a Hollywood producer. As you can see here, he has worked on X-Men, Captain Marvel, and King. Anyway, and this is a faithful emulation of his own studio, to the point where if Alan actually updates something in his studio, you get a free upgrade of the plugin. So they actually update it. And so it has some basic functions here. And you get.
So is this one of those things where you have your headphones and you say, I have headphones of brand X, model Y, and it's going to apply some EQ curve trying to simulate that space for you?
Yeah, and the usual HRTF, head-related transfer function. You can actually personalize it. You can personalize it by, it has an app for your phone. You can take a picture of your right ear, and then it compares it to a database of ears, and it tries to find the best HRTF for you. My dad actually used a similar app called Creative XSFI, SF, whatever. I don't remember the name, but it's a bit more complicated than that because you have to take pictures of both your ears and also your head shape. Yeah, it's the future. But in this one, I'm going to use the generic HRTF. I didn't use the personalized, so all of us can hear the same thing. And I'm using it in tandem with Ria's Surround Pan, which is a relatively new addition in Reaper. You can see it in 3D here. An annoying thing about it is that you can't create a custom speaker setup when you're in 3D. You can't touch the speakers, so you have to use this 2D. But in this view, you can move the sound sources, and I'm going to demonstrate this right now. I'm going to play a sound file that I created myself. It's just a little modular jam that I made in Cardinal, so you're not going to get any copyright strikes.
Thanks.
Yeah, I care about you. I care about this stream. Let's turn it down a bit. Can you hear it?
Yes.
Good. So I'm going to bypass the plugin first. And now I'm going to turn down again. It sounds different, right? A bit spacey, a bit metallic.
I have the
But
hardest
this-
time hearing these differences. Can you perhaps play the thing? And
Yeah, I'm going to play it in a loop, but I'm going to show you exactly how the specialization works.
okay.
I'm going to move these things. The white and the red circle are actually the left and the right channel of the stereo track that I'm playing. So I'm going to move each one separately, and I'm going to move them across the 3D space, and hopefully you will hear the difference.
I think I know what it is. Skype is mono.
Oh,
Yep.
okay.
Yep.
But still,
Yeah.
yes,
Well,
too bad.
maybe for next time we can set something up using some other tool. When Arya
Okay.
and I are streaming together, we used it used to be called OBS Ninja. Now it's called Video Ninja, and that is
Oh,
stereo.
okay.
But yeah, Skype is mono, so that's one reason I was not hearing anything.
Oh, so maybe I can stop this presentation about this and demonstrate the sound in a different, in another meeting. But anyway, I can demonstrate the sound in another meeting. But what I wanted to show you is that here you can use these presets, but it didn't have the 7.1.6 setup that Alan Meyerson is using, because he's using this specific setup. And here, sorry, it's a bit annoying. You can actually mono and solo the channels. It's pretty good. It's really, really nice as a design standpoint. The only thing I don't understand is why they felt the need to add 2 pictures of Alan Meyerson and Eva Reistad staring directly into your soul. I don't know. Your mixes better be good because Alan is watching you.
One thing that I did is I was playing around with this plugin / app called SonarWorks.
Mm-hmm. Oh yeah, Sound ID, SonarWorks. Yeah.
Yeah, I also played with Auto EQ, which is this GitHub repository that has a bunch of EQ curves for different headphones.
Oh yeah. I've used that. I use it in Equalizer APO. I think I'm running it right now.
Yeah,
with,
exactly. Yeah, if
with
you are on
this
Windows,
thing.
you can use this app called Equalizer APO that equalizes
Yep.
the output of your whole operating system. So any app running in the operating system will be equalized. I couldn't hear any difference.
Yeah,
I
I'm
turned
using
things
a-
on and off, and I was like, "What what is this making? And I saw the EQ curve and it was like all over the place. I couldn't hear any difference. It was not sounding any flatter to my ears. I may not have golden ears, I guess.
Oh no, the thing is that even if here I have a copy of the Auto EQ repository, and even if you find your own headphone model, they have different EQ curves from different measurements. One is from headphone.com, one is from Reference Audio Analyzer in my case, and I chose them. I picked them all one by one until I used one that I really liked. And you can see the EQ curve here.
But do you think it makes a lot of difference? Or is it very simple?
To me, it does, at least in my headphones and in this setup. I'm going to... it's going to be in mono, but you will hear it. And also I'm using crossfeed. I don't know if you noticed, because it is a bit relaxing on the ears.
Fair.
Yeah, it's not exactly a fair test because the audio is getting louder. But if I play it back a little bit, you may notice that when I turn on the EQ, not only does it get quieter, but also the bass is more pronounced and some of the resonance is gone. Let's go again. You may have noticed that the kick drum is actually a bit bassier and a bit more accurate. I don't know if you noticed it.
I don't. I guess I don't have ears that are trained well enough.
No.
Alessandro, what do you hear?
Maybe it's the Skype's fault.
Alessandro, do you hear me?
Can you hear us?
Hello?
Hello.
Yeah.
What do you hear? Do you hear a lot of difference when Fotis is turning that thing on and off?
Not really, but I remember using something similar for a while as well, and it was a really subtle change, but it was there when I tried it for my own headphones.
And you liked it? Do you still use it?
I don't use it anymore because I was too lazy to keep it up, and the difference was not that big.
Yeah, that's my impression too.
I don't know, it worked for me.
Fair, of course.
Yeah, and the one thing I wanted to show is that, like I was saying before, there is a 7.1.6, but it's not the one Alan Meyerson is using. It's the Auro 3D, which is created by a rival company to Dolby. It's not the Dolby Atmos setup. Auro 3D is a company that's created their own codec, and you can see that there is a speaker on the ceiling, and they're calling it the voice of God. No, I'm serious. That's literally how they call it.
Okay.
But unfortunately, this format failed, and I'm hearing that the company is going bankrupt because this setup forces you to place your speakers on the ceiling. But Dolby made a workaround on that. So this is a regular overhead speaker that similar to what Alan Meyerson is using. But Dolby knows that a lot of people don't want to drill holes on their ceiling. So instead, they made this solution. They're calling them Dolby Atmos enabled speakers. These are actually firing the sound on the ceiling, and they land on you. So you get the impression that the sound is coming from the ceiling. And you can't really do this because you would have to install a speaker on your actual head, on your chair. And so the company is going kaput. But yeah, so I had to create a custom speaker setup, and I created a preset, and I uploaded it to Stash, and you can actually download it. And it already has 3 downloads. Nice. And please, please, please vote 5 stars. So I look cool. And yeah, I can't demonstrate it now because Skype is mono, but I'm going to show you the pictures. So for the first time in this study group, I'm going to actually show my first plugin ever, the organ. Oh no, it crashed. Sorry. My plugin is very bulky. It's very CPU hungry because it was created on a terrible framework called Maze, and then I'm never going to use it again. And I'm hoping I will be able to recreate the whole thing in JUCE, because I am sick of getting bug reports from users, and I'm being like, sorry, I cannot fix that. So
well, if you receive bug requests, that is great.
Yeah, that is really great. Yeah, but no, I'm not saying that it's a bad thing. The bad thing is that I'm saying I cannot fix that because it's not my fault. It's Maze's fault, and there is nothing I can do.
No, but I get it. I'm just poking fun at when you misspoke and said bug requests, because if only my users send me bug requests, I would have some for them. I can provide them with bugs.
I can stress test your plugins anytime you want. So yeah, this is my plugin in all its buggy, glitchy glory. Do you like it? Do you like the appearance?
Yeah, it's cute.
Thanks. I'm hoping if I make it in JUCE, I will be able to actually make the UI resizable. So my experiment, this is the drum setup, the microphone setup that my friend Bill is using. At least in this setup, you can see it here. So it has 5 microphones: the kick, the snare, the room, and the 2 overheads left and right. And I wanted to recreate this in rear surround pan, and I did it. At least I hope I did. So the white is the kick, the red is the snare, the yellow is the room. No? Oh. Wait, I think this went the other way. Yeah. And these are the 2 overheads, but this was supposed to be higher. I think I accidentally overwrote an earlier version. But yeah, if I could actually show you how it worked, that would be great. But Skype is mono.
Yeah,
but
next time.
I routed. Yeah, I did this thing because I routed all of the outputs into the rear surround pan. You may have noticed that this is a bit to the right because I did this hack. So the OHL is always on the left and the OHR is always on the right. And so rear surround pan is getting the 5 outputs from there. You can actually set the outputs from here. And then it outputs 14 outputs that the Alan Meyerson plugin is able to decode into virtual surround. So it worked. And yeah, that's all I had to say about it, is that I made an experiment and it worked. And I'm happy about it. And now I would like to see how I can fake something like this on my JUCE port or remake of this plugin.
Nice.
And now I'm going to turn off my... Please vote 5 stars. Vote 5 stars. And I'll shut up.
All right, okay. So anything else that you all would like to add?
I think I'm okay. Is anybody asking something on the chat?
I think I was able to catch all the questions as they came up. So with that, let's wrap this up. Thank you very much, Fotis and Alessandro, for joining us. I hope to see you again in 2 weeks. Thank you, everyone who was on the chat, Tail, M9, Bo, and people who are watching but not necessarily active on the chat. Also, thanks, Beats Besteln. I am not pronouncing German right. Anyway, I see you all again here tomorrow. I will continue my Automixer 2.0. And yeah, see you in...
You're going to get a lot of bug reports from me.
And bug requests, hopefully.
Bug requests, yeah.
All right. Thank you all very much, and have a good one. Bye.
Bye.
Bye-bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.